Consider we have an object constrained to travel in a circle at angular velocity omega 0. I'm assuming rigid rotation here, so the object is also rotating as it goes around. Maybe it's on the end of a stick. We can write down its kinetic energy as half I0 omega 0 squared for some moment of inertia I0. Then we spin the object around a different axis with some additional angular velocity omega 1. Is there an easy way to write down the combined kinetic energy? We might hope that we can write down a sum like this, but it's not correct. Conventionally, what we would do is to decompose the motion into the translational motion of the center of mass, shown in red here, and rotation around the center of mass. Now we can sum these two components of kinetic energy. Note this is only true if we use the center of mass as the rotation axis. But you can see in this case the path of the center of mass is quite complex, so it can be quite inconvenient to write the kinetic energy this way. Let's see if we can derive an expression for the kinetic energy of the two superposed rotations. R here is some arbitrary point on the object that we're going to integrate over. The velocity at the point R is the sum of the two rotational components, R cross omega 0 plus R minus R1 cross omega 1, where the angular velocity vectors here point out of the page. We integrate the kinetic energy over the object, substitute in V, expand out the squared binomial, flatten the cross products, do some rearrangement, and we end up with this. Two terms that look like standard rotational kinetic energy terms, and a cross term in omega 0, omega 1. I found this form really nice to work with, and I hope you do too. As usual, there's a little more detail in my blog, especially better definitions of all the symbols.